Okay. Hey, everybody. How's it going? My name is Carlo Bobilis, and I'm actually the moderator for this session. I'm pleased to introduce today's speaker. Just make sure I'm on. Perfect. Tech advocate for Cisco Learning and Certifications, Jason Belk. But before I hand over the mic, I have a few housekeeping items to cover about today's presentation. Today's webinar will be recorded and made available on demand after the live session. Since you've registered, you'll be emailed that information afterwards. If you experience any audio issues, please use the call-in number that was displayed on the screen previously, but I'll make sure to post that information in the chat momentarily. So without any further ado, and to go ahead and start the session, Jason, over to you.
Awesome. Thanks, Carlo. Hi, everybody. I'm Jason Belk, and just a little bit about myself before we get started so you know who I am. I started Cisco as an intern, went in Cisco IT and was a network engineer for several years and did network automation in the campus and branch team. Left Cisco, went to a small consulting startup called Network to Code, came back to Cisco, and have been teaching network automation ever since. And so for me, it's a passion to help network engineers get started in network automation because I felt the struggle when I was on call and trying to figure out how to learn this stuff and going through documentation and examples. And I wish I had these types of resources available to me. And so I'm going to try to explain it in such a way that it'll be hopefully helpful for you getting started and remove that barrier to entry. Basically today's session is going to be a lot more hands-on than maybe you're expecting. I'm not going to do any slides. I'm going to just focus on demos and walking through examples and trying to explain things to clear up any confusion, and I'll also get you started on your automation journey. So I'm going to have my screen up here on the side just so everything's bigger for you, but I'll be looking up on the side from the camera just for your information. Okay. So first, Ansible. Ansible is owned by Red Hat, and it was open source, originally focused on automating compute infrastructure and cloud resources. But what we're going to be showing today are primarily network engineering use cases. So fairly quickly after it was developed, people started also using it to configure their network devices, iOS, Nexus, ASAs, and so on. And really the core components of Ansible are the playbook, which you see here, and the inventory, which I'll pull up as well. And what Ansible is really good at doing, let's pull it to the side, I'll just do it, is configuring network devices. So it's a runbook style automation engine where you have an inventory that lists your devices. It can be a static file like this, or it could be pulling from an API or a source of truth like Netbox or other places. And you have the names of your network devices on the left here. So you name your network device. And this is really important for Ansible to know what you're working on, as well as how it's going to connect to it. And these variable names I have here of Ansible Network OS, Ansible Host, these are special keyworded variable names. I didn't make these up. Ansible is expecting these particular values. And I'm using an INI style format. You can also use a YAML style format to describe your inventory. So your inventory are the list of devices, whether those are compute, network, or other resources that you're going to be working with. And you can group them into network device groups. The way you do that in the INI style format I have here is using these square brackets. So I have two groups of iOS XE and Nexus. And then there's a default implicit group within, and you'll see this across a lot of different things talking about Ansible. There's implicit things, which basically means that there are certain variables or keywords or things that Ansible just uses as its own nomenclature. And so if you've been using Ansible for a while, it's second nature, but if you're just getting started, it's hard to know which variables, which keywords are ones that I just made up because they work for me, and which ones are built into the system. So I'll try to call those out specifically. So the all group is built into the Ansible ecosystem to encompass all of the devices that you have in your inventory. So, and then you can define variables that are then applied to all of the devices. So I have all : vars to say, hey, all of the devices in my inventory, I want to have these variables applied to them. And these are also built-in variable names that Ansible is expecting to look. You obviously, in a production environment or even your lab environment, wouldn't want to have your username and password just sitting here plain text in a file, but for teaching purposes, this makes things a little bit easier for everybody. And so you have these built-in variable names of Ansible user, Ansible SSH pass, and Ansible connection. Obviously, username and password is going to get plugged in behind the scenes for Ansible to connect to our network devices. And then this Ansible connection is something, if you look at the documentation, you can see there's different types of devices you can talk to: network devices, compute, storage, cloud resources, and so on. And so by saying Ansible connection network CLI, it's telling Ansible, hey, all the devices I'm working with today are going to be network devices. And then furthermore, on my particular devices, I've defined on a per line basis the actual network OS. Ansible doesn't know by default what type of network device. You're never going to talk to an iOS device. It's different than talking to a Nexus device. If you even think about it as a network engineer, when you're logging into the device, there's different little tricks when you're logging in or navigating the prompts that are different between different platforms. And so primarily today, we're going to be working with the iOS devices. Just to, when you're teaching something, it helps to focus in on simple one type of thing. And then as you know more and more about the automation, you can start expanding into other domains. But this is just more for demonstration purposes. We have 4 network devices: Internet Router 1, Disk Router 2, Disk Switch 1, and Disk Switch 2. And I'm using the reservable NSO sandbox, not because we're using Cisco NSO, but I just like the sandbox. I used to work on the NSO team, and it has a great topology that I can also use Ansible to talk to those same network devices. And so I'm connected on a VPN, and I'll be talking to these network devices with these particular IP addresses using these particular OS types. And for the main part of Ansible is the playbook. So it uses the YAML format, and you'll see lots of text here. And if you haven't looked at YAML before, I highly suggest working through examples, looking at how the different things. But I'll be talking through some of the different components here. So on this YAML playbook, it's going to be looking for an inventory file to define a lot of these assumptions that we're talking about who are my devices, what are my credentials, what are the IP addresses, what are the device types. None of that's defined in the playbook. The only thing that we have in the playbook to remind us that we're talking to network devices is at the top here at the play level. We have our hosts, which we're saying iOS XE. If you remember in our inventory file, we have iOS XE, and this has to be spelled exactly the same in your playbook as your inventory. That was one mistake when I was first getting started that always frustrated me, is I would, put maybe a hyphen in here, or, I would do different things that would make it just slightly different from a human eye, but from Ansible eye, it won't be able to make that assumption for you. So we're working on those 2 iOS devices, first play. And a playbook basically consists of one or many plays that each of those plays have a set of tasks. And this will make more sense as I go through examples and I show them running in action. So a play, each has a play definition in YAML format. You'll see we have a hyphen here, which in the YAML style says we have a list. We have a name that's optional, saying, hey, this is what this particular play is going to be doing. Here's the devices we're going to be working with. Here's the connection type we're going to be working with. Gather facts I'm not going to talk about right now. We'll talk about that in a further play. And then we have this play level key here, tasks. And you'll notice that this next level of indentation on the YAML is indented over under the task. So this play has one task, and I've defined them saying play 1, task 1, just to help people understand, but people don't always do that. So you kind of have to use your eye to see where the plays and tasks happen. And within the tasks, they have what are called modules. And modules, if you've done any programming or been exposed to other code, modules are effectively functions. They're abstracted packaged things that have defined inputs and outputs. And what we have here are the inputs. And so the name of this function, the name of this module is debug. And the one thing we're going to work with here is message. So this is basically going to print out for us this particular statement with these curly brackets as variables. And these are built-in variables I'm also using within Ansible. They're good to know. Inventory hosting basically tells Ansible, hey, I want you to work with whatever device you happen to be working with on this particular task. Because you'll remember our iOS XE has 2 devices. And so once we hit this first task, it's going to be doing both those devices at the same time. If you have 15 devices in your group, it'll do 15 devices more or less at this all at the same time and wait till they're all done before it moves on to the next task. And so this playbook is going to start in the first play. It's going to print out this statement with the first device name has network OS, the network OS name, and then continue on doing that same thing for a second play for the Nexus devices. And then it's going to do the same thing for all devices. Now let's go to the terminal. So the command that you're going to be using is Ansible-playbook-I to specify your inventory file so Ansible knows what devices we're going to work with. And I've named my playbooks using numbers just to help me focus on which one's going to come next. And you'll notice if I push enter, it's going to run the playbook. It's going to pull in that inventory file. It's going to print out the statements that we were discussing. And I'll scroll up a little bit. So we can see play one. It has the name of the play, task one. Host name is Internet Router 1 with a network of iOS. So it pulled that in from the inventory file. So we have Internet Router 1, Dist Router 2, same thing for the Nexus devices. And then the third play is for all the devices at the same time. And then you'll notice at the end of a play, everything that's green went well. It'll say which ones changed, if there are any network changes. In this case, we're just printing out stuff, so nothing changed. And then it'll say if there are any errors, but in this case, it's pretty simple. So nothing went wrong. So oftentimes the debug module is used just for purposes of as you're developing to see what the outputs of particular variables are. Because especially when you're working with multiple devices and lots of variables, it's easy to get to lose track of where everything is and what you're working with. So I'll go ahead and move now to actually talking to a network device. So we have here a playbook. Remember, we're using that inventory talking to iOS devices, and we had this one just one play. So we're not doing 3 plays like the last one. We just have one set of devices talking to iOS devices, and we have 1, 2, 3, 4, 5 tasks. And so each of these tasks are going to execute sequentially, and that's how Ansible works. It does all the devices for one task. Once those devices are done, it moves on to the next task, and it does them kind of in parallel using Linux processes. And so what we have here is a new module called iOS command. And you'll notice I have the cisco.ios part, and that's more recent developments in Ansible have basically included what they call namespacing because they've started expanding their community, people adding more and more of these methods slash modules. And so you don't have to include that for older versions of Ansible, but newer ones, you're going to see this additional kind of preface. Anyway, so iOS command is going to send enable level commands to our network devices. So it's going to send a show version to our 2 iOS devices. Task 2 is going to send 3 show commands. And you'll see this input here is commands. And if we look, it's like, how did I understand what to work with here? And I think this is also an important tool when you're working with Ansible is referring to the documentation. So I'll just pull this up here. I Google searched and pulled up Cisco iOS Ansible. It pulls up all the different modules. So they have specific ones for very specific use cases and more general purpose ones. I find the general purpose ones like command that we're using right now, config, are more commonly used, but I'll go through an example of what they call the resource modules, the more specific ones as well. So looking at the iOS command that we're working with right now, the documentation, if I scroll down, it has all the parameters listed out for us. I'm not going to go through all the parameters, but I usually, when I'm looking at these things, I scroll down to the examples and I say, okay, what am I going to actually work with here? What are the parameters? In this case, we have fairly simple commands, the list of commands that we're going to send, and that the documentation if I want to see all of the possible options. So we can send one command, we can send a list of commands. It's going to send that against multiple devices. And there's also another more recent features that they've added in terms of parsing output. If you've worked with automation for a while, you'll realize that sending show command output and just seeing raw text for lots of devices can get pretty tedious to try to figure out programmatically what the actual output is. So I wanted to show in this example the Cli Parse module. So Cli Parse has a couple of different options. I'm using the network to code templates, which I'm more familiar with, which basically means that behind the scenes they use a templating language called TextFSM to take that show command output, in this case, show IP interface brief, send that through some coding magic, and then it turns it into a list of dictionaries. So that way we have specific values and keys that we can then, in a list-oriented format, take that output and then programmatically take out just the pieces that we want. So I'll run that command, and that way we can see what's going on here. -I inventory, and we're doing number 1. And I'll run it once, and you'll see that a lot of the show command output actually doesn't show up in the default run. So you can see, oh, it ran the commands, but I can't see the output of the commands. So by default, the way Ansible works, because remember, it's working in compute originally, it doesn't show those output of commands. So if I want to see the output of those commands on those first tasks, I need to add a -V. And I think this goes up to 4 or 5 Vs for what they call verbosity, for looking at the behind the scenes things that are going on. You can see some additional things going on. So oftentimes when I'm running Ansible playbooks, I almost always run them with at least 1 -V, just so I can see the raw output of what's going on behind the scenes. Because when I'm testing, I want to develop, I want to see what the particular output is. So now I'll scroll up. We have our first task, success. We did our different commands. We had Remember, we did one command for show version. We did another command for 3 sets of commands of show IP interface brief, show interfaces directory. And so it just prints out, here's the show interfaces output for gig 5, gig 6, loopbacks, the dir output of one of the devices. And remember, it's doing both those devices pretty much at the same time. And then the more interesting part, because I think we've all seen show version outputs, is this task 3. When you do that parsing style, we now have the show IP interface brief output in the list of dictionaries. And so we can see we have our interfaces in a list of dictionaries with particular keys of int_f for the interface name, IP address, protocol up, status up. And once we have in this parsed output, it's one of the huge powerhouses in Ansible is being able to then take that structured data output and then feed it into other decision-making processes. Since this is just an intro session, I'm not going to go deep dive on that. Our next session, we're going to cover more on variables and more about the variable ecosystem and all that fun stuff. But I just want to get you the basic building blocks. So we have this really cool structured data output. And what I can do with that is I can take that list of dictionaries, extract out the particular keys and values, and then plug it into a debug statement. So if I look at my task 5 here, I take that output and I use a set fact, basically to say, hey, take the output of this particular module and then save it to this variable name called set fact. And then this interface is NTC is the name of the variable. I print it out to the screen just so we can see what it is. And then I can take that particular variable and then extract out the first list element, extract out the first dictionary element to then print out the name of the interface and then the name of the IP address. And if we look at here, we have the first interface for Internet Router 1 is Gigabit Ethernet 1 with an IP address of this particular .181. Same thing for Disk Router 2. So that's, I think, really where the power of Ansible starts coming in. After you've gone beyond, wow, I can send a lot of show commands to a lot of devices pretty quickly and do things with it. You can also start using these parsing engines to take those values and then programmatically make decisions on them, because you can do conditionals, loops, things like that. But right here, I'm just showing a basic example where you take that particular variable output, we use the curly brackets to denote a variable, and then plug it into a debug print output. So now I'll show to disk. This next one is doing show commands. So we're working still with iOS devices using the iOS command. We're storing that output. In this case, register versus set fact. There's some nuances, but they both basically save it to a variable name. So we have show. It's saving the output of our show version now and show interfaces in this new play, and saving it to the show command output. And then now we're using one of the other features that's not talking to a network device. This is a module called File, where you can actually create files and folders. And that seems like, well, I could just do that myself. But this way, I don't have to do it myself. My automation creates the structure of the place where I want to put my outputs for me, and it makes sure it's present. Because if you've done any automation, you'll quickly know that if you start dumping files in places that have directories that don't exist, it's going to throw an error. And so having that built into your automation, that's I feel like one of the strong parts about Ansible is being able to not only send automation to your devices, but you have these utility features being able to configure and set up and your file structures, directories, Jinja 2 templates, all these kind of things, which we'll talk about in the next session more, to be able to not have to worry about where things are going. So anyway, so we have task 1 sending the show commands. Task 2 is going to create this directory called show outputs. And I find these are the particular inputs for this module of where it's going to go. I want to make it a directory, and this is my Linux basically saying I want to have it this particular permission level. And then this last one is basically using what is called the Ansible Jinja 2 template module, which basically feeds in the output of our show commands into this new show outputs. And remember, the inventory host name is that special Ansible variable that says whatever device I'm working on right now. And it could be one or the other, whichever one it's working on. So it's going to create a file name based on the name of the device _show commands.txt. So this is where some of those kind of fun features start getting in. So Ansible playbook, save some time typing. We'll go to our second one. And it's going to be running our show commands to the device. And then it's going to be saving those show commands to the memory. And we have our show interface output up there. It's actually creating the show outputs directory, and then it's up here. It's basically saying, hey, I dumped that file for those 2 devices into the directory. And the yellow here is actually good. The yellow is telling us that, hey, I actually created and I did things successfully. Something changed, because one of the features of Ansible is called idempotence, where if you run the same command more than once, it's not going to recreate that file structure. So it'll check to see, hey, that file structure is already there, or in the case of doing configuration changes, it's going to check the devices and see idempotently, I'm not going to make changes to the device. I see the running config already has the commands that are there. And so what we have here, we can see in my VS Code, we have our new show outputs with our two new files based on our device names of disk router 2, internet router 1. Our show commands, we have our show version for the first device and our show interface output, and same thing for the second device. So now let's talk about iOS facts. So one of the other really powerful features within Ansible is what are called facts. And you'll see I have gather facts no, because by default it gathers facts, which takes additional time and kind of slows down the runtime of your playbooks. And also older versions of Ansible didn't work with network device gathering facts, but now it's much more consistent. And so basically what we can do there is we can use this facts module to say, hey, I want to have Ansible talk to our network devices, parse a certain subset of information, and then now store it into a variable. And so I'm going to take that variable, store it in there. And I think it's easier to see exactly what those facts are, but basically they're a set of commonly used pieces of information for your network devices, and they change per platform. So it'll have things like iOS version, the names of your interfaces, the names of the IP addresses, the name of the platform, and all that kind of stuff. And if I scroll up here, it has these pre-built variable names based on what it just ran in. It did a bunch of show commands to our network device in the background. It parsed all that information for us and put it into memory. So it has the running config, it has the platform, in this case is CSR1KV, our OS version, it has all of that in memory. And basically that my playbook, the first one gathers the facts, prints out some of the information, and then prints it out to the screen. So one of the cool things in our next play that we'll do, it's very similar to this, is we'll do it for 4. Let's see, while in the background, I'll explain the playbook. So we have our first task also takes the facts, stores into a variable called raw facts, make sure that that show output directory exists, because you always want to make sure that the place that you're putting your file exists. And then we're using a copy function to basically take the output of our raw facts and then feed it into a Jinja 2 template. In the next session, I'll talk more about Jinja 2 templates, but I'm using this from Barry Weiss's neat example of a facts template where it takes, remember those names of those variables we had in our facts, we know what the names of those variables are, and so we can have Ansible actually feed in those particular values from our devices. So Ansible net host name, model, iOS type, and then it does some looping here. I'm not going to cover the looping in this session, but all that to say is we can see the output here of what those values are going to be. So when it ran the facts, it'll take all that information, feed those variables into the template, and then do a looping across all of our interfaces. So the facts really helps you give you a good baseline for exactly what's going on with your network devices, and then be able to then make decisions off that, build reports like this for your different network devices. And all these examples are going to be on GitHub, so you're welcome to take an example and walk through it in a slower way yourself. And now we'll move on to configuration. So we'll take a simple configuration example here, where we're just going to use the iOS config module. Similar to before, we have a list. In this case, the parameters named lines instead of commands. Everything's not always consistent in Ansible. So they have a list of cd run, ld run. It's going to run these 2 config commands. And then we also have an example here where sometimes in iOS you have what they call config stanzas, where things are kind of shifted over. And in those cases, like for interfaces, we have what is called the parents also input. So the parent says, hey, the config stanza is under the interface 1 through 37. And then within that config stanza, we want to issue in a description IP address. In this case, I have the IP address stored as a variable for a host var. So for the sake of time, I'm not going to talk about host vars. We'll talk about it in the next session. But it's going to plug in a particular IP address for us that I've stored somewhere else associated with the particular devices, and then it'll configure those devices. So if we go to Ansible playbook -I inventory, and we'll do 5 to make our configuration. And so it's going to send our configuration lines to both those network devices. We see, yep, we sent CDP run, LDP run to both Internet Router 1 and Disk Router 1. And then we have also sent those commands of the loopback to the 2 devices. So I'm going to skip over the config resource modules. Basically, Ansible also has a way to configure, apart from just doing config lines, you have a way to have modules that are purpose-built. This one's, for example, is for L3 interfaces to just do one specific part of the configuration rather than any type of generic configuration you want to be working with. For this last example, I'm going to show we have a big ACL file, and I'm not going to actually send it, but you can send a huge ACL file to the device and then send a ping, and then you can run this example on your own as well. So I'm going to comment out just to show you how the commenting work. I can hit Command and the backslash, and that will take all of these lines and then comment them out, just to save us a little bit of time. But I want to show you this ping module because you can also, they have a purpose-built ping module that's pretty cool. This is for number 7, Ansible Playbook, -I inventory. So right now it logged into the network device. We're using the ping module on this particular destination that's within the VLAN that we have set up within our particular sandbox environment. We're going to take the output, we're going to send 2 pings, save it to an output, and then take that ping output. I'd ran the previously, so I know what the particular keys and values are to then print out the particular packet loss and the RTT average. So it ran in the background, and in this case, we sent the ping 172 repeat 2. It has 0% packet loss. Same thing for the other device. And then I took the structure of this list in dictionary values and then plugged in the variable name. So we can say the ping test result has 0% packet loss with an average of RTT average of 5. And the last component I wanted to show here is number 9, cleanup config. Because this has one component that I wanted to call out, is that sometimes when you're testing playbooks, you'll notice that when Ansible fails on a particular task, it will not continue on to the further tasks in the playbook. So in this particular playbook, I'm actually removing all the configuration that I put in my examples. So I'm using the config module to say no CDB run, no LDB run, and for the access list that we didn't get to because it would have taken several minutes to deploy the hundreds of lines of ACLs that we were doing. This one's actually going to fail because we shouldn't have the access list there. And then we're also going to remove the loopbacks we added, and we're going to remove, in this case, use the file module to remove the show outputs directory and remove the backup directory. So if I go to Ansible Playbook, -I inventory, cleanup config, it's going to now log into those devices and then issue the no commands to take out CDP, take out all the DP. I'd say this is one of the weaker parts of Ansible, is that it's great at deploying new configuration and maybe pushing out updates. But one of the downsides is that once it's there, it doesn't have any knowledge of the state of what's in your network. There are ways you can get around that and tricks to that. But Ansible is basically a CLI tool, as you see it here. It doesn't have a database. It doesn't have a way of parsing the configuration and understanding what's going on. It just does exactly what you told it to and then turns off. And same thing with Ansible Tower. Ansible Tower is basically Ansible plus some APIs to be able to then execute your output. So you'll notice here that we had some of these fail, and that was because it was trying to remove something that actually didn't exist. And so we saw that was the case, but the ones that did remove were successful. And if I didn't have that ignore errors at the top here, at the play level, it would have actually exited at the particular task that was failing. And so from there, that covers everything that we covered today in terms of intro to Ansible. Hope this is helpful. We covered a lot of ground. So we covered all the way from inventory file. The one last thing I'll mention is the Ansible.cfg. So there is some system level configuration that sometimes you want to do in Ansible, and it looks for in your current working directory, your Ansible.cfg file. And you can do things like set up, hey, this is where my inventory file is going to be. I don't want to check for my host keys. You know, if you're working with a lab environment, you have different host keys for different VMs coming up and down, things like that, where this is an optional thing that you don't have to put in there, but it does help to have these kind of more configuration for the application itself at a broader level. So I think that'll wrap us up from there, Carl, and really appreciate everybody's time.
Awesome. It's a lot of information, Jason, and I do see that we received a ton of questions. And although we're it's a 30-minute session, I do encourage everyone to jump on on the Cisco Learning Network forums to continue the conversation. We'll be looking through the questions that we have here. A couple ones that I can kind of help out is
Sure.
VS Code, right? Jason, is that's the IDE that you're currently using? It's a Windows platform. But nowadays you can run, VM images, you can set up a Windows box, but other IDEs are available, right?
Yeah.
You have
so VS Code
PyCharm.
VS Code runs on every platform, Linux, Mac, PC.
Oh, see, there you go.
So it works on all those. I really like it because it makes it easy to connect to remote hosts. So if I'm working with a virtual machine, Docker container, sandbox, VM, things like that, this remote button here is really helpful to be able to just like with a click or two to basically turn your IDE to then be able to then be configuring remote files. That's a whole nother session. But I will mention I do have a Docker file in here. I based on Barry Weiss's great Docker file. And so if somebody doesn't have an environment that they want to mess up in terms of installing Python packages, this will set up a Docker container that has Ansible installed and everything's set up, ready to go. I tested it myself. And we have a requirements.txt file that says, hey, these are the versions of Ansible, Paramiko, NetMiko that we're working with, because older versions of Ansible, the examples might not quite work. Things change over time as the application evolves.
Awesome. Thank you very much, Jason. Again, just to remind everyone, please, let's go ahead and continue the conversation. We have tons of great questions on the Cisco Learning Network, and we can look at it further there. The link is in the chat. And actually, give me one sec. Let me place the QR code for those who maybe are on their mobile device. So let me quickly just take the presenter ball back. All right. And this is the QR code itself. So feel free to scan that there. This will take you directly to the thread that I've opened up on the forum. But I do encourage everyone to go ahead and open up another thread, ask questions. We'll be monitoring the forums and engaging with everyone on there as well. Jason, is there anything else you'd like to say before we wrap up?
I just want to thank everybody for coming and mention that the next session we'll cover more in depth on Jinja 2, YAML, variables, like some of the bread and butter that people typically think of Ansible, but I really wanted to cover the basics of the playbook structure and modules and not even worry about the complexity, because that's a whole session on its own. So I'm really looking forward. I hope everyone appreciates what we covered today.
Awesome. Thank you very much, Jason. I've placed his Twitter link as well as his GitHub repo, as well as we have a new YouTube channel, which let me get that pasted into the chat screen. So you should see that shortly. We thank everyone for joining us today, and we do hope to see everyone on our next session. I believe it's September 27th, same time at 10 a.m. Pacific. Thank you very much, and we'll see you next time. Take it easy. Bye.
Okay, thanks.